Hi guys, you want to introduce yourself?
I'm Arjun.
And I'm Avika.
Okay, so we're going to talk a little bit about physics, correct? Okay, so can you tell me what is physics?
Physics
Mhm.
is the simplest way to describe what's happening around us.
That's a fair description. Okay, so Avika, can you tell me why would we want to learn physics?
It's so we because it's nice to know about what's happening around us
Mm-hmm.
and just what you're doing wrong.
Okay, anything else?
So that we can use it to our advantage. What we know about physics, we can use it to our advantage.
Okay, that has enriched human life a lot, right? From airplanes, buildings, to flying, to everything, right? All right. Any of you, can you tell me like different branches of physics? Do you know any branches?
There's thermodynamics.
Okay, what does that deal with?
That deals with temperature.
Like heat. Okay. Anything else?
And there's also electricity, and there's electricity, magnetism, and
Yeah, electricity, magnetism, and light. They all deal with.
waves.
That is correct. Anything else? Any
There's
other?
also Newton's laws of motion.
Correct, yeah. So there's Newtonian physics. Is there any other physics that deals with like really?
There's general relativity.
Okay, what does that deal with?
That deals with black holes.
Black holes, yeah. There the Newtonian laws don't apply, correct? Is there any other place that Newtonian laws don't apply?
And tiny atoms.
In
which
tiny-
you need quantum physics for.
That's where quantum physics comes in play. That's excellent, guys. So let's talk about some one of the oldest branch of physics, right? What is that?
Mechanics and movement.
Mechanics and movement, that's correct. All right. So before we go into all big mechanics and become engineers, we need to know some fundamental things about it, correct? All right. So are there any terms that you've learned, Avika, in mechanics?
Um,
Yes, Arjun, you want to help?
There's speed,
Uh-huh.
velocity, and acceleration.
Okay, louder, okay? Speed, velocity, and
Acceleration.
acceleration. Avika, do you want to tell us what speed is?
speed is the
It's okay. Arjun, you want to help?
Speed is the rate at which an object moves.
Correct. Rate at which an object changes its position, correct? All right. What does rate mean, Avika? Do you know?
rate means overtime.
Over time, that's correct. All right. Can you tell me how velocity is different from speed?
It's at one direction.
Yeah, so it's the speed with the vector in a particular direction. Arjun, can you tell me where velocity would be more useful than speed?
In relative velocity.
Okay, what is relative velocity?
It's where if there are two objects
Mm-hmm.
and they both have velocity
Okay, and they both are moving.
and they both are moving,
And okay,
and the relation between them.
okay, the velocity between them, the
Yeah.
speed between them in relation to each other. Right, that's good. That's good. So it depends, right? If they're moving towards each other and they're moving away from each other or in the same direction, the relative velocity, they're all going to be different. Correct? That's good. And let's go to acceleration. That's a little bit confusing. Who wants to tell about acceleration? Okay, let's try with Avika.
So acceleration is when say a car was moving.
We'll come to the example, okay? We'll come back to example. But Arjun, what is acceleration?
Acceleration
Mhm.
is velocity speeding up. Is the rate at which it
Changes.
velocity is-
Yeah, it changes. It can increase or
Yeah.
it can decrease, right? That's an awesome definition. Avika, do you want to give us an example of that?
Say an object was moving
Okay.
at 6 miles per hour.
Okay. And now let's say that gets an acceleration of 1 mile per hour, right? So what happens now?
So every hour,
Mm-hmm.
it changes its speed 1 mile.
Okay, so like,
So if it was going at 6 miles per hour,
uh-huh.
next hour it was moving,
Uh-huh.
it'd be going at 7 miles per
Then
hour,
8,
8 hours.
then next hour 9. So what is the acceleration here? 1 mile.
per hour per hour.
Yeah, the velocity is 1 mile per hour and it increases by that amount per hour. So how do you tell it? Simply?
Simply, you could say it 1 mile per hour square.
That's excellent. That's right. All right. Okay. So let's move on to the next few concepts of
Inertia,
uh-huh.
mass, and weight.
That is absolutely right. Who wants to talk about inertia? Okay, Arjun, go.
Inertia is one of Newton's laws,
Okay.
and it states that one object will stay in its state of rest or motion unless acted upon by an external force.
Oh, that's a very good definition of inertia. Now, what about mass? What is mass? Yeah.
Mass is how much matter an object contains.
Okay, how is that different from weight?
Weight
Mm-hmm.
is the force
Mm-hmm.
pulling on the mass
So it's the force applied by the
by
mass,
the mass.
under the influence of gravity, right? Okay, so the mass is same anywhere in the universe, right? But your weight changes according to the gravity. Like an astronaut can weigh a lot lesser on the moon because the gravity is less, correct? All right, so now let's get into motion, correct? So motion, what is one concept that you learned? Momentum, correct?
Yeah.
So what is a momentum? Can anyone explain?
Momentum
Mhm.
is the force at which an object is going.
Well, it's not the force. Well, let's say when an object is moving, you want to stop it, right?
Yeah.
So some things are harder to stop and some are easier to stop.
Yeah.
So how harder is kind of the concept that momentum is explaining, right?
Yeah.
What does momentum depend upon? It depends on two things, right?
It
Which one?
depends upon mass
Uh-huh.
and it depends upon
Velocity.
velocity.
So a truck and a toy car moving at the same velocity is going to be a lot harder to stop the truck than the little toy car, right? Yeah, so that's the concept about momentum. Now, can things spinning around an axis have a momentum? So what are those called? What is
That's
that called?
called angular momentum.
Angular momentum, that's correct, and we'll come back to that. So let's go to the famous Newton's laws of motion. How many laws are there, Vicky?
3.
3, all right. Do you know the first one? Go, Arjun, go.
That one we've already covered. It's the law of inertia.
Inertia. Okay, let's go with the next one. Arjun, go.
The next one
Mhm.
is, it states that acceleration
Mm-hmm.
is directly proportional to the force
Uh-huh, yes.
and inversely proportional to the mass.
That's absolutely right. So what does that mean, like directly and indirectly?
So that means if the force goes up, then the
Mhm.
acceleration goes up.
Okay, that's correct.
And if the mass is more,
Uh-huh.
then the acceleration is less.
Yeah, that's inversely proportional. That's very well done. That's very good. So what is the last law, Miss Avika? You're right. You're right. You know it.
Every action has an equal and opposite reaction.
There you go. Well done. So is there an example that any of you can give that explains all? There you go. All 3 laws. Okay, let's go, Avika.
A cannon.
A cannon. Okay, tell us how.
How? First, when you put the powder,
Mm-hmm. So first, there's a cannon,
yeah,
and there's
it's
a
just waiting there.
and there's a
And there's
cannonball.
a cannonball.
So if you let them be, they're gonna be that way forever. That's
Yeah.
first law, right?
As long as you keep them there, they'll
Yeah.
stay there.
So what is that called? That they won't move unless you do something to it. What is that called?
That's the law of inertia.
Yeah, that's inertia. They're gonna just stay there. Okay.
Yeah.
Next, what do we do?
And then
Mm-hmm.
once you put the spark, once you spark it,
Uh huh.
then there's an explosion behind it.
Yeah.
So then
That force is applied
that
to
force
the
is applied
to the cannonball, right?
cannonball so that it goes.
Goes. Okay. And how fast it accelerates depends upon what?
Depends upon the force
Force. And
and the mass. If the mass of the cannonball is bigger, then the acceleration is less.
so that's the second law, correct? And what is the last law? How is that demonstrated in this example?
The last law is demonstrated whenever, like when the cannon is going,
Uh huh. There's a
there's a reaction to make it come back.
yeah. The cannon moves back a little bit, right?
Yeah.
Is there any other example you can think of?
For the third law,
Yeah.
like if you're on ice,
When
Uh-huh.
you're on ice,
Uh-huh.
if you throw something
Yeah.
back when you're on slick ice,
Yeah.
and you go back.
You slide back,
like,
right?
you slide back when you throw the
Yeah, that's also the conservation of momentum. The ball that you threw gained a positive momentum, you moved back, that's a negative momentum, correct? Okay, now let's come back to the orbits and angular momentum, right? Okay, what is an orbit? Who knows what is an orbit? Okay, go ahead.
the track
Yeah, or the path,
or
right?
the path
Huh?
on which a
The path that is taken by an
By
object.
Going
that
around
going
another
around
object.
another
Correct, that is the orbit. Now planets go around the star all the time, right? So what does so they have an angular momentum, correct? So what does that depend upon?
That depends upon the mass,
Hmm.
and it also depends upon
The
The
distance
distance
from
from
the
the
center. Yeah, distance from the focus actually.
Yeah, distance
What is
from
the
the
path? Is that the orbit of the planet? Is that a perfect circle?
no.
No,
What is it?
it's
Yes, surgeon?
It's an ellipse.
It's an ellipse. It's almost a circle, but not quite. Right? Okay. So, does the Earth always move at the same speed?
no,
No. So how does it change?
because sometimes
Uh huh.
it's farther away from the sun
Uh huh.
than other times,
Yeah.
and the acceleration is always the same.
No.
So-
the mass is always the
The
same.
mass is always the same.
Correct.
So it has to go faster when it's closer to the sun.
yeah, because it has the momentum, right?
Yeah,
The
it has
momentum
the
has to be the
momentum
same. And
be
if
the
the
same.
mass is the same and the distance becomes lesser, the velocity has to increase, correct?
Yeah.
That's awesome, guys. That's really good. So then next we come to the awesome concepts of
Energy,
uh-huh.
work, and power.
That's awesome. So what is work?
Work
Mm-hmm.
is not laundry.
Yeah.
And
Well, it's kind of that
Yeah,
too,
kind of
but
is.
in terms of
in
physics.
terms of physics, work
Mm-hmm.
is how much force is needed
Mm-hmm.
to move an object
Mm-hmm.
to another
To a certain
to
distance.
a different distance.
Yes, that's force applied over the distance, correct? That is awesome. And how is it measured by?
It's measured in Newton.
It's measured in newtons.
Well, that's the force.
Yeah,
We also have the
it's
distance.
Newton meters or joules.
That is absolutely right. And how about energy? What is energy?
Energy is the capacity
Mm-hmm.
to do work.
Capacity of a system to do work. Do you guys know the different kinds of energy?
There's kinetic energy and
Mhm.
Potential energy.
Can you explain, Amika, what is potential and kinetic energy?
Potential is whenever it's waiting there.
Yeah.
The energy is just waiting,
Yeah.
and it's just stored there.
okay.
And kinetic
Mhm.
is whenever the force is going.
Can you give an example how a kinetic energy is converted to potential and potential to kinetic?
Whenever you pump water,
Yeah. Up to
Yeah.
pump it up, right? Okay.
And the force that you use,
Uh-huh.
the energy that you use is converted into the water.
Into
and
no, it's not converted into water. The energy stored as potential
yeah,
energy, right?
stored as potential energy in the
In the
whatever you're
system,
pumping
yeah,
it into.
yeah.
And then it's just waiting there.
Uh-huh.
And then once you open the
Tap.
tab,
Yeah.
you get the water, and then it automatically turns.
Flows
into-
in. Yeah, that's a good example. How about power? Who knows what power is?
Power
Uh-huh.
is the effort to
Well, it is the rate at which
rate at which you expend energy.
expend energy. That is correct. So what is the units for power?
For power, you use watts.
Yeah, it's based on
James Watts.
what did he do?
He invented the steam engine.
Steam engine, right? And at that time he used to show how much power each engine has, and he compared that to
Horses.
horses. So he said
We call it
horsepower.
horsepower.
That's right. That's right. Good job, you guys. And now let's go to something that makes our work
Simple
easy.
machines.
Yeah, simple machine. What is a machine?
A machine is something that helps you do work.
Well, it helps you do work, but even better way to tell it is it decreases your effort to do the same work. Yeah, it does help. Yes, that's correct. So, how do we measure how much can a machine help us? How much it is helping us?
We measure it in machine advantage.
Mechanical and
Mechanical.
that is correct. Mechanical and so, what is the mechanical advantage?
Mechanical advantage
Mhm.
is the factor
Uh huh.
at how much it multiplies your work.
That is correct. So, what is work? Work is force
Force
over the
over the
distance,
distance.
right? Force into distance, right? So, that is always laws of physics, you can't change that.
Yeah.
So, but if you want to decrease the force, you want to move the thing at the same distance, but you want to put less force. So, what do you have to do?
Increase the distance.
Exactly. Can you give me an example of that?
So the liver,
Okay.
there's a weight on this end,
Uh huh.
and then the pivot is right here.
Okay.
Then the force that you push,
Uh huh.
and so the further away from the pivot the force is,
Uh huh. Yeah.
the easier it is to lift it
So
up.
that way, the best way is to move the pivot closer to the weight. Or any other example, Avika?
A ramp.
Yeah, ramp.
Stairs?
That's even better example. I like it.
So instead of climbing a rope up straight,
Uh-huh.
you can take a ramp or stairs.
Yeah. So you go for a longer
It
distance.
takes longer distance, but it doesn't take as much energy.
Yes, a lot easier, correct? A lot effortless. And now some difficult concepts of deformation, stress, and strain, right? So what is deformation, Arjun?
Deformation is when an object
Hmm. When a force
Changes.
is applied, it changes form,
changes
right?
form.
Okay.
It usually happens to those that are stationary,
Okay.
like walls.
All right. And what kinds of deformations do you know?
There's elastic deformation
Correct?
and plastic deformation.
That's excellent. What else? There's another,
And then there's also a fracture,
which is like breaking,
which is
right?
like breaking.
So what is whenever there is an elastic deformation, you apply weight and it changes its. Go ahead, explain that.
So when there's elastic deformation,
Mm-hmm.
you apply force,
Mm-hmm.
and then it changes shape,
Mm-hmm.
but only as long as the force is applied. If you take away the force, it just comes straight back.
Yeah, like a spring or
Yeah.
something like that, right? But if the only to a certain extent, right?
Yeah, only to
If you apply too much
much
weight, after which
It'll,
it goes back,
it
but
goes back, but
not
Not
as
as
much.
much.
Okay, and the change in the original length and the new length is called what?
strain.
Strain. And the weight or the force that is needed to change that, to cause the strain, is called
Stress.
stress. That is absolutely right, you guys. Absolutely. And now the famous gas laws. Well, gases are different than solids, right, Arjun? How is that?
Because
Okay.
Because if you fill the cup with some gas,
Hmm? It just occupies the whole.
it just act up. If and you put a lid on that
Mm.
cup,
Mm-hmm.
And then
Mm-hmm.
we put it into a bigger jar
Mm-hmm.
and take off the lid. All the gas will come out,
Yeah.
but still be in that too.
Yeah. So
And it'll
just,
take as much space
yeah,
as
so
it
it
can.
just occupies the whole container, right?
Yeah.
The molecules are loosely bound to each other. That's excellent. And how many? So the laws that govern the gases are kind of different than the solids, right? So what are the laws that you know, Arjun?
There's Boyle's law,
Okay.
which has to do with
Mm-hmm.
um, uh,
Pressure and volume, right?
pressure and volume.
So how are they
So,
related?
If the volume is inversely proportional
Mhm.
to pressure,
Exactly.
so
that-
if there's less volume,
Uh-huh.
there's more pressure,
Yeah.
and if there's more volume,
There's-
there's less pressure.
For the given amount of temperature, that has to be stable, right? Yeah. What is the next law that you know?
Charles' law.
Excellent.
It
What
has
is-
to
what
do
is-
with
uh-huh.
volume
Uh-huh.
and temperature.
Excellent. And are they directly or indirectly proportional?
They are directly proportional.
Exactly. So you increase the temperature, you heat up something, the pressure in the system increases, right?
Yeah.
Excellent. And what is the third one?
The third one is Gay.
Gay-Lussac's law. Yeah.
Yeah,
So
Gay-
what does that deal with?
That deals with pressure and temperature.
And are they directly or indirectly proportional?
They are directly.
Yeah, so if you increase the pressure, the temperature increases, right? But the volume has to remain
Yeah,
constant.
volume has to
Of course, that's a given. Understood, right?
Mm-hmm.
Now, let's just touch a little bit on fluids. We've gone over 20 minutes. We wanted to wrap this up real quick. Let's touch a little bit of fluids, okay? Are gases fluids?
Gases are fluids.
In physics, yes. Yeah, that's right. And can you tell me some properties about fluids? Just one property. Say viscosity, right?
Yeah.
So what is viscosity?
Viscosity is
Mhm.
the resistance of flowing.
Resistance to flowing,
Yeah.
yeah. Like thick syrup is more viscous than water, right? It's just what we call thickness of the
Yeah.
fluid, right? Okay. And the famous Bernoulli. Let's finish it with Bernoulli effect. What is Bernoulli effect?
The
Can you give an
Bernoulli.
example for it?
You have an example? Okay. All right.
The Bernoulli effect
Mm-hmm.
is whenever whenever the air flows faster,
Uh-huh.
there is less pressure.
Exactly.
And whenever it flows slowly, there's more pressure.
Can you give me some example?
So if you have two
Okay, there you go.
So,
Can you help us get two papers which are right there on the table? Okay, yeah, go ahead,
so
Avika.
if you have two sheets of paper
Okay,
and you hold it like this,
all right.
same size,
Yeah.
and they
Okay.
And-
I think we
and
have some
below-
papers. Let's see. Can you show? Let's see if you can demonstrate this. Let's see if it works. Oh, Bernoulli, don't let us down. Physics laws always work, okay? Anywhere and everywhere. Okay, go ahead, blow. Now, if you blow in the center, everyone thinks the papers are going to go away from each other, right? Let's see what happens. Oh, they're sticking to each other, even though Avika is blowing in the center.
and then if I blow here, it'll come.
Yeah, it's going away from there. There you go. So when the air is moving faster between the papers, there is less pressure and the outside pressure is more. So they're pushing the paper towards each other, right? Any other famous example?
the airplane.
Airplane. Yeah, the wings are
Yeah.
designed in a way where the air moves faster on the top, pressure difference lifts it up and take off, right? That was excellent, guys. Let's go have some fun, okay? Very good.